So in this class, we will discuss about the multiplication theorem in probability. So multiplication theorem is also one of the important theorem, and also it is one of the important concept coming to the probability. So we can derive this multiplication theorem formula and from the conditional probability. So what is the formula of conditional probability means P of A given B equal to P of A intersection B by P of B. So from that we will derive this multiplication formula and also we will see the definition of the multiplication theorem. So first of all, we will discuss what do you mean by multiplication theorem. Suppose there are two events. So, suppose we are conducting some experiment. So from that experiment we are taking two events. Suppose if those two events are occurring simultaneously, or if two events they met at the same, and whenever those two events meet at that time, that is called multiplication theorem. So what do you mean by multiplication theorem means? So it is nothing but it is the probability states that whenever two events meet, it means whenever but there are two individual events. Whenever those events meet, or whenever the event A and event B must happen simultaneously. Suppose there are two events. So if those two events will happen simultaneously, then it is called multiplication theorem. So that is called the multiplication theorem. So that is the definition of multiplication theorem. See here, the probability of simultaneous occurrence of two events A and B is equal to the product of the probability of the other given the first one has occurred. So this is called the multiplication theorem of probability. It means whatever the two events that occur simultaneously, those two events are equal to the product of probability of the other two events given that first one has occurred. So that is called the multiplication theorem probability. In other words, we can able to say that whenever two events happen simultaneously, so those are said to be in multiplication theorem. So and also the probability of occurrences A and B happening at the same time given the first event has already happened is the product of the probability of each event according to the probability multiplication theorem. So that is what we have seen. So when do we use this multiplication theorem means? So suppose there are two events A and B. So whenever event A and event B are happening separately, then at that time we have to use this multiplication rule in order to determine the likelihood that they will happen together. So and also the intersection of two or more outcomes from the sample space is calculated using the multiplication rule. So suppose there are two samples, suppose there are two events A and B. So between those two events there are some intersection part. So those type of intersections are part of two or more outcomes. Suppose there are multiple outcomes. So from that multiple outcome there is some intersection part. So in order to calculate those intersection part, we have to use this multiplication rule. So that is the so now we will see theorem. So here multiplication theorem. So we will see each theorem. So there are three theorems of probability which are explained below in detail. So now we will see those three theorems of the probability. First theorem: if A and B are two events associated with a random experiment, then P of A intersection B equal to P of A into P of B given A. If P of A is not equal to 0. Next, or P of A intersection B equal to P of B into P of A given B if P of B is not equal to 0. So this is the theorem 1. So what is the formula of multiplication theorem means? P of A intersection B. So if you want to get the intersection part, what we will do is we have to take the probability of A. It means event of A part and probability of B given A. So whenever you multiply those two, you will get the intersection part. So that is what it is saying. Otherwise, P of that is also we can also written it as P of A intersection B equal to P of B into P of A given B. So likewise, we can also derive those type of formulas. And next one is P of B given A is equal to how can we write this P of B given A P of A intersection by P of A or P of A given B equal to P of A intersection B by P of B. So this is the conditional probability formula. So next one. node point. So in the node point, what it is saying is the conditional probability P of A given B is not different if P of B equal to 0. Suppose what is the formula for conditional probability means here we are having P of A given B equal to P of A intersection B by P of B. So if we want to define the conditional probability, this P of B must not be equal to 0. If this P of B is equal to 0, then we cannot define the conditional probability because something divided by 0 is not defined. So if you want to define the conditional probability, this P of B or denominator should not be equal to 0. That is what the first rule. Next one, P of B given B equal to 1. Next one, remark. So next one is if A and B are independent events. Suppose A and B are independent events. It means those two events are occurring independently. It means there is no relation between the event A and event B. Then what we will say, how we can able to derive means, so P of A given B equal to P of A and P of B given A. That means A and B are independent event means P of A and P of B given A. It means we can, what is the formula of the multiplication theorem is P of, what is the formula for conditional event means P of A given B equal to P of A intersection P of B given A, that equal to P of B. It means we can, what is the formula of the multiplication theorem is P of A intersection B equal to P of B P of A into P of P given A. So suppose A and B are independent events. So P of B given A will become P of B. So that is what it is saying. So if A and B are independent events, so the P of A intersection B equal to P of A into P of B. So that is the point that we are discussed. So next one, next case. Next case C. Suppose if A and B, C are three events associated with a random experiment. Suppose we are taking three events. So those three events are associated with a random experiment. Then how can we derive this multiplication rule? Means P of A intersection B intersection C equal to P of A into P of B given already event A has happened. Next one is P of C given A intersection B. So that is what the formula. So this is the another case which we are discussing. So next one, next theorem, multiplication theorem of probability for independent events. So for how will be the multiplication theorem for independent events? We'll see now. So if A and B are two events with positive probabilities, suppose if we are taking A and B are, suppose if we are taking A and B are two events and with possible positive probabilities, and those and also P of A is not equal to 0 and P of B equal to not equal to 0, then only we can able to say that in A and B they are, so then A and B are independent if and only if, so if and only if P of A intersection B equal to P of A and B. So what it is, what does this theorem is saying is, suppose if we are taking two events with positive probabilities, it means P of A is not equal to 0 and P of B is not equal to 0. Then when can we say this P of A and P of B? If P of A intersection B equal to P of A and P of B, it means if there is no relation between the A and B, then we can able to say that A and B are independent of each other. So now we will see the proof here. So here see, I am taking a P of A intersection B equal to P of A into P of B given A, or otherwise I can able to take P of B into P of A given B. So here P of A is not equal to 0 because already we have already the condition is given in the above. So that's why we have to take that. Now we are saying if A and B are independent, that is, if A is independent of B and B is independent of A, it is that means there is no relationship between the A and B. Then we can able to say that P of A given B equal to P of A into P of A and P of B given A. That means P of A in intersection P of B given A, that equal to P of B. Because A and B are independent of each other. So P of A given B equal to P of B. So that is the second point. So from 1 and 2, so substitute the P of A given B from the equation 1. So from that we will get P of A intersection B equal to P of A and P of A into P of B. So whenever two events are independent of each other, then we can able to take P of A intersection B equal to P of A into P of B. So that is what the theorem is saying. So now we will see the example and we'll discuss each problem. So see the first one. Find the probability of drawing a diamond cut in each of the two consecutive draws from a well-shuffled pack of cards. And if the card drawn is not replaced after the first draw. Suppose there are well-shuffled pack of cards. So how many cards will be there in the well-shuffled cards? 52 cards. So from the 52 cards, um, they are asking probability of drawing a diamond card in each of the two consecutive draws. Suppose if you are taking two draws from the 52 cards, they are asking what is the probability of drawing a diamond card. So from the two consecutive draws, they are asking the probability of diamond card. It means what is the probability of getting a diamond card from the two consecutive draws. And also if the card drawn is not replaced after the first draw, it means after drawing the first one and the card is not replaced with that. So they are asking that. Now we will see the solution. So what we have to take means A will be suppose we have to take the A event. So A will be the event of drawing a diamond in the first draw. So drawing a diamond card in the first draw will be the event of A. And what is the event of B means drawing a diamond card in the second draw. So those are the two events. Now probability of drawing a diamond card in the first draw means 13C1 by 15 to C1. That is 13 by 52. So how many diamond cards will be there? So the 13. So out by what will be the total number of cards? 52. 13 by 52 equal to 1 by 4. It means the probability of drawing a diamond card in the first draw is 1 by 4. Okay. So after drawing a diamond card in the first draw, 51 cards are left out of which 12 cards are diamond cards. It means already we have taken 13 diamond cards. So already from 52 cards, already we have taken one card. It means after taking one card, how many cards will be left? 51 cards will be left. So in that 51 cards, already we have used 13 diamonds. From the 13 diamond cards, already we have taken one. So out of 13, we took one. So how many are left? 12 cards are left. So that is what it is saying. So next one. So we have probability of B given A. It means probability of drawing a diamond card in the second card when diamond card has already been in the first row. It means suppose if you drew a diamond card in the first row and from that condition they are asking probability of diamond card in the second row. So what will be the probability? So now we are saying 12C1 by 51C C1 because already we have used one diamond card out of 31, so 12 are left. That's why 12 C1 by. So out of 51 out of 52 cards, already one card is drawn. So how many are left? 51. So 51 C1. So 12 by 51 equal to 4 by 17. So that is the probability of drawing a diamond card in the second draw when diamond card has already been drawn in the first draw. That is what it is saying. So now the required probability is probability of A intersection B. It means they are asking the common part between the two events. So P of A into P of B given A. That equal to 1 by 4 into 4 by 17 equal to 1 by 17. So they are both are independent of each other. Sorry, they are not independent of each other. According to the multiplication theorem, 1 by 4 into 4 by 17, we got the 1 by 17 as the final answer. Now we will see and discuss about the second example. Now, a bag contains 19 tickets. Suppose there is a bag. In that bag, we are containing 19 tickets. Those 19 tickets are numbering from 1 to 19. So now, suppose a ticket is drawn and then another ticket is drawn without replacement. It means we have drawn one ticket from that 1 to 19. After drawing one ticket, again another ticket is drawn without replacement. It means after drawing the one ticket, we are not replacing the ticket with another ticket. Like that, we have drawn another ticket. So they are asking after that, find the probability that both tickets will show even number. It means whatever the ticket that we have drawn, they are asking both the tickets should show even number. So we have to take the two events. It means have to take two events. So what is the first event? So event of drawing an even number ticket in the first draw. So we are drawing the first ticket from the 19 numbers, and that should be the even number ticket. So that is the event A. So what is the event B? Drawing an even number ticket in the second draw. So in the second time we are drawing the ticket from the 19 cards. So that should what should be the even number ticket? That is what it is saying. So now there what is required for us? So the required probability equal to P of A intersection B equal to P of A into P of B given E. So we have to find the value of probability of drawing an even number ticket in the first day and P of B given A. So already we are having 19 tickets, that is number from 1 to 19. And so in that bag already which are 9 are even. It means 1 to 18, what are the even numbers possible? 2, 4, 6, 8, 10, 12, 14, 16, 18. So how many are there? Total 9 possible numbers are there. So so there are 9 possible even numbers from that 19 cards. It means we should want only even number from the first draw. It means we want only 9 numbers. So the probability of drawing an even number ticket in the first draw is 9 by 19. So out of 19, we want only 9 even number cards. So that's why the probability of A equal to 9 by 19. So this is over. Now the ticket drawn in the first die is not replaced. It means we have drawn the first ticket. After that, we didn't made any replacement with another ticket. It means we are drawing the second from the 18 tickets. It means already we have taken one and there is no replacement. How many tickets will be left? 18 tickets. So out of 18 tickets, how many will be the even number? 18. Why 8 are even number? Already we have chosen one even number in the last. In the last. So already one even number is completed from the 9. So how many are remaining even number? So 8 are even 100. So probability of B given A equal to 8 by 18. That equal to 4 by 9. So now we are substituting this value probability of A intersection B equal to probability of A into probability of B given A. That equal to 9 by 19 equal to 9 by 19 into 4 by 19. That equal to 4 by 19 is the final answer. So this is the solution for the example. So now we'll see the example 3. So it is 8 is to 5 against the wife who is 40 years old, living till she is 70. It means we are having the ratio 8 is to 5 and against the wife who is 40 years old and person who is 40 years old living till she is 70. So till the age of 70 years he is living and 4 is to 3 against her husband. So 4 is to 3 people 4 is to 3 people are against to her husband and they are living against her husband till 50 years. Husband now 50, living till he is 80. Means up to the age of he is 80, they are living and find the probability that both will be alive. So how many years they will be alive? They are asking the question. So first we will have to define two events. What is the first event? They are asking both will be alive means uh, both wife and husband will be alive. So A is suppose I am taking two events. First event is wife is alive. Second event is husband will be alive. Now we are taking probability of A equal to 5 by 8 plus 5. So 5 by 8 plus 5 means wife will be alive. So we have to take the wife. So the ratio is min is to wife, husband is to wife. That's why wife by um, wife plus husband. That is 5 by 13. It means probability of A complement equal to 1 minus P of A equal to 8 by 13. So wife will be alive is 8 by 13. So husband will be alive is 3 by, we have to take the 4 is to 3 ratio. That is 3 by 4 plus 3. That equal to 3 by 7. So 4 is to 3 is the husband ratio. 8 is to 5 is the wife ratio. So for wife, we have to take 8 is to 5. For husband, we have to take 4 is to 3. That's why probability of B equal to 3 by 4 plus 3. That equal to 3 by 7. So if you want to get only husband will be alive, means that is probability P of B complement. Already we know the already we know the formula of probability of B complement, that is 1 minus P of B, that equal to 1 minus 3 by 7, that equal to 4 by 7. So that is the probability of A and probability of B. Now we have to assume that this A and B are independent. So if we assume A and B are independent, then A complement and B complement are also independent. So whenever those two events are independent of each other, what we can say means P of A intersection B equal to P of A into P of B. Here probability of A and probability B are independent of each other because there is probability A is wife, B is husband. So there is no relationship. It means there is, according to the concept, there is no relationship between the A and B. So that's why they are independent of each other. So whenever they are independent of each other, already we have seen in the um, theorem P of A intersection B equal to P of A into P of B. Now we have to take 5 by 13 into 3 by 17. That equal to 15 by 91. Next. Next one, none will be alive. None will be alive means P of A complementary intersection P of B complementary. That can be written as P of A into P of A complementary into P of B complementary. Already we got the values of P of A complementary into P of B complementary. After substituting that, I got the value 32 by 91. Next, only wife will be alive. So only wife is alive and husband is dead. It means we can take it as the P of A intersection B complementary. That is equal to P of A, that can be written as P of A minus P of A intersection B. So we have to substitute this formula. So after substituting the formula, I got the solution 20 by 19. So next one, what is the next part? Only husband will be the alive. So only husband will be alive means um, P of A complementary intersection B. That can be written as P of B minus P of A intersection B. So after substituting these values, I got the value 24 by 91. So that is the another example. So those are the examples. So in the next session, we'll discuss the another examples. So till now, uh, what are the problems that I discussed here? Hope everyone understood and everyone got the point how to solve the problem. In the next session, we will solve the remaining problems that are remain for the next class. So we'll discuss those things in the next class. So until then, watch this video completely, and if you really like it, please share and subscribe to your friends, and also please do comment if you want any videos. Um, if you want any videos that you are expecting from me, please make a comment on the comment section so that I will respond to your comment. So thank you. I am ending up this session. So thank you guys. Bye.